Alright, thanks for checking out our channel here. This is going to be hopefully a repair video on a Blitzer 25 mile unit. This is, they make a newer version now. It looks kind of like this, but a different case, more square than this kind of curved, sort of shape to it. This particular model is a 2012 unit based on when it was built. The first two numbers, the serial number is the year it was built. So sometimes the newer ones have like an EC. I don't know what that's saying, or maybe electric charger. I don't know. But anyways, the first actual numbers are the year it was built. But this particular unit, the note on it says, hold on, output unit of a unit only measures between 3,000 and 5,000 volt at best. And okay, I was reading the note that I read on there. But anyways, about Blitzer, Zareba, Red Snapper, American Farmers to the Tractor Supply, they don't offer any more parts for their units. Back in August of 2023, they sent out letters nationwide that that as of November 1st of 2023, they were no longer going to be selling any parts. They were getting out of the parts business altogether. So if you have a unit that is within warranty and fails, you'd call them up, prove warranty to them, and they'll send you a new unit at no charge. If it's out of warranty, they'll tell you to throw it away and buy a new one, or buy another one of the units and then keep that one for spare parts, I guess. But so no parts are made for these things anymore. So what we've been doing for even before then, probably the last 5 years, we've been retrofitting different parts in these at times when we couldn't get, because they've had back order issues for a long time. So most likely what's wrong with this is the output transformer is probably bad. We'll take the screws out of it, because we said it clicks and pulses or whatever, but the output is 3,000 to 5,000 volts at most, which isn't terrible, but that's not what it's supposed to be. Most likely it's output transformer's bad. I don't want this thing open. Kind of work our way around. It should just pop open, but it may not have been open in the last 12 years, so it's kind of gotten sticky. Alright, there's the ants got inside there. Dead ants. Alright. Okay, so most likely our issue is right here in this transformer. Alright, so let's plug it in and verify that the issue that he's stating is the issue that we see with it here. So we're going to turn this on, and we're going to look at peak voltage across the terminals right here. That's a fence and ground terminals. So we're going to plug this unit into the wall here, turn the power strip on. That's clicking, good sign. But let's put our tester across here and see what it reads with open circuit. So there will be no joules on it because we're doing open circuit, it's not doing any work. We're getting about 3.2 kV, 3.7, 3.9, 4. It's kind of bouncing around a little bit. Yeah, definitely lower than what it's supposed to be. So our transformer is most likely our issue. We can test capacitor as well, just to make sure it's good, because it's 12 years old, so might as well check the capacitor. These transformers pull out pretty easy. The capacitor could be weak, microfarad wise, but I don't think that will keep our voltage from being as low as it is. We can test the capacitor just to see what it reads. This particular one is a 7.5 microfarad capacitor, so let's put our meter on microfarads and we'll test it. We'll unplug one of the wires, plug this red wire from the capacitor just to take it out of circuit, and we're going to look here, and we'll see what kind of microfarads we get. There's no polarity of the capacitor, so let's put our meter across there and see what it reads. .57. So capacitor is fine. So our issue's in the board. So what we're going to do is I'm going to cut these, because we're not going to use this transformer, or we're not going to use the factory one because you can't get them anymore. I'm going to snip this transformer off, but we're going to, usually some put the wires, you slide a new one in and you're done. But our transformer is a little bit different, and the wires on that transformer on ours are a little short, so they won't reach this. So we'll use these wires here to make our wires a little longer to extend into them. And let me go get my transformer here. Put that junk one there. I'll be right back. Alright, so we're going to use this transformer here. This can be used all the way up to about a 4 or 5 joule unit at most. Don't want to go any larger joule wise than that. You'll probably overheat this little thing and burn the coil on the inside. But it has 4 wires on it, kind of like this one did. But it's got, this one has like a third little winding wire in there that powers that runs that little bulb, and there's a resistor on there to protect that light bulb. Well, this doesn't have that extra winding. It doesn't have a light bulb on there. The majority of the time, those light bulbs burn out anyways, so most people don't care about the light bulbs being bad, or the unit not having a new light bulb on there. It still thump and click and pulse and all that stuff. It just won't have a flashing light. Like I said, most times those lights, excuse me, are burned out anyways, even when they're good. The lights are just, it's a cosmetic thing. Won't keep the unit from running. Just nothing to do with that. Alright, so what I like to do is I'm going to cut these wires a little short. Or not short, but cut off some of the wires sticking out. And we're going to solder and heat shrink the primaries of the wires on the transformer, as well as these wires over here, and then we'll solder them together, because you can use butt connectors, but that doesn't always work real well. I mean, it works fine, but then if you don't get a good enough connection, all the energy that's being discharged through that primary, there's a little air gap in that butt connector. It's going to start arcing and burn up that butt connector, and then it's no good. And then you have to fix it all over again. So better just to solder it, heat shrink it. So let's find my heat shrink here. Knocked off the shelf here because I think a cat in the shop here, she climbs on stuff and knocked some shit off the top there. Okay, that's too small. I need a bigger heat shrink. I think that'll work. I'll use So we'll just slide this one down here, other red one down here, and then we're going to solder black to black, and red to red. We're going to heat them both up. I'm going to stick them side by side. Since they're both covered in solder, side by side, and it's going to touch them together, heat them up, and shit. I had a bad angle. Thought that was going to happen. I can add a little more solder to this one here. Okay, this ought to do better, I think. There, a lot better. Okay, bend these around. I'm gonna add a little bit more solder to that. Should be able to lay on top of each other, side by side or whatever. Heat them both up. Oops. Okay. Now, we'll take this heat shrink, bring it up there, bring this one over there, and then I don't have a my old heat gun that I've had for a long time finally kicked the bucket and I don't smoke, so I don't have a lighter with me. I bought a new heat gun, but I can't, where the hell I put it at? So I take a soldering iron. My soldering iron is set to just about 800 degrees Fahrenheit. So we'll just rub it across here, and this will shrink that heat shrink up. Same thing over here. This one, don't want to hold it in one spot too long, so I don't want to melt it. It takes longer, but it works. Alright, let's get this board back down in this little holder here. Alright, so now this transfer is just going to sit right there. It's a little thicker and wider, so it doesn't sit in there nice and, because it's the thickness of these plates that are on here, how many there are. This one's got about 20% more probably plates in it. Okay, so now, of course, black is our ground. So we're going to, only thing that we sometimes have to do to this is sometimes these things will put out like 13, this transfer with this combination, how this thing's wound up, it might put out 12, 13, 14,000 volts out of it. That's just way too much. So what we'll do is, I've got a big resistor, like a 10 watt, like 400 ohm resistor. We'll put that across on the inside to keep the voltage down low, or lower to around like 7, 8, 9,000 volts. But well, we may have to do that, we may not. Depends on how this thing goes. Let's see what it does first. Sometimes we don't have to do that. Sometimes it's right in the range we want it to be. I guess it depends on the board, how it's built, and what parts are, on it and everything. So here, before we crimp these on there, let's just test it and make sure it's working. All right, so let's plug it in here. Turn it on. Clicking along here. my power supply or my tester on. $12,000 volts out of it. Let's see what a 500 ohm, because we're going to put a 400 ohm load. So let's see what a 500 ohm load does. We're going to put a 400 ohm resistor across the inside. But let's see what a 500 ohm brings it down to. 8.7, which is where we kind of want to be in that 7 to 9 kV range. I think this is the resistor I need here. Let's see what size this is. Yeah, 400 ohm. So this is the resistor we're going to put. It's a 10 watt 400 ohm resistor. So what we'll do is we'll strip a little bit of this off. Just a little bit. And we're going to wrap it around here. Near kind of the, not quite at the base of it, but up a little ways. And we'll do the same thing over here. And I'm going to solder it on this so that way it doesn't slide around and come off by accident. And then we'll crimp on the female spec connectors onto here. Come on. Okay, now we'll put on no load on my meter, and see it's got a built-in load now, but we'll put it. See what it reads just for shits and giggles. 7.6. So right around that 8,000 volt range, which is where I want it to be. So, because we don't want, you have too high voltage on certain situations, it can shoot a spark across an insulator to a fence post, and then you'll have all kinds of things arcing out and stuff. Everybody thinks, oh, I want 15,000 volts. You don't need that. It's the joules that gets them, but you need about 5,000 volts or more. Alright, positive for the fence is over here. Ground is over there. There we go. Just like that. Alright, so now put this thing back together. Sometimes when we use this transformer, the case won't shut. I'll show you what you got to do. It's kind of shutting, but not all the way. So what we got to do is, you got these four little stubs right here. This one, this one, this one, this one. They kind of cupped around the old transformer. Kind of went around it on the edges there. Well, this is a little thicker and wider, so these little things are actually hitting the transformer. So you take a pair of snips, you know, just snip it off. Just snip it off, kind of just, I don't know, 1/4 inch of it comes off. So you just kind of snip off the excess that you don't need. That closes just fine. Alright, so now we're going to put our screws back in it. This one's done. So if this had been I went somewhere else, probably would have, oh, I'm sorry, sir or ma'am. Can't fix this one. You gotta buy a new unit. Something rolling around inside here. That hurts something. Come on, get in there. That cord's wanting to move on me. There. All right. Let's see what kind of spark it'll throw. We are good to go. All right, well, thanks for checking our channel here. And if you haven't subscribed, subscribe if you'd like. Hit the thumbs up button. Until next time, see you later on.